All right, we're back. We're still on page 2 of notes 10. Notes 10. Yeah, notes 10 of Calc C, and we are working with Taylor series. We don't want to make a table. We want to try to use a series that we already know to create a new series. And when I look at this problem, I think sine is something I could work with. So I'm going to try that. And so usually these just work out, right? Like you look at it and you're like, this is crazy. But like the person writing the problem probably is asking you to do it because it's a thing that can be done. So like, don't worry about that so much. All right, so sine of u is, sine is odd, so it's u minus u cubed over 3 factorial, u to the 5th over 5 factorial, and so on. So this is going to be u, which is x squared, and then minus x squared cubed is x to the 6th because you multiply the exponents, 3 factorial plus x cubed to the 5th, so x to the 15th over 5 factorial, and then minus x cubed to the, what are we doing? 1, 3, 5, 7, 7, 3 times 7, 21 over 7 factorial. All right, I got myself all confused here, so I'm pretty sure that's right. Plus, this will straighten me out. X squared to the 2n plus 1, so that's x to the x squared to the 2n plus, I feel like I started using 3 at some point instead of 2. I think that's what I did. I think that's where I got confused. So we're going to go back and fix that. These I'm pretty sure are wrong. Okay, so x squared to the 2n plus 1. You know what? When in doubt, so this is x to the 4n plus 2. 4n plus 2 over 2n plus 1 factorial. Okay, so 4n plus 2. 0 gave me 2. 1 gave me 6. 2 gives me 10. Okay, we're adding 4. Holy cow. All right, sometimes you get lost. Yeah, you get lost. You try to fix it. Uh-oh. I think the lawnmowers might be here. Uh-oh. Now we're going to subtract x squared. So should I get up and close the windows? I mean, I probably should. So I'm going to do that. I don't know. I'm not pausing it. Don't worry about it. Yep, got it. Here we go. I'm back. We're doing this. All right, we're subtracting x squared. We only have one x squared to subtract though. And so this x squared is going to get knocked off. And we just have minus x to the 6th, 3 factorial, x to the 10th, 5 factorial, x to the 14th, 7 factorial, plus. So I mean, technically, if I want 4 non-zero terms, I need to do another term. But since we already had the lawn mowing delay, I'm going to not do that. Oh, look at me with plus dot, 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 plus dot, dot, dot. Okay, so we got that. Now, remember, our goal is to get this. So we're going to divide everything we see by x. So sine of x squared minus x squared divided by x is every single term gets divided by x, right? So now we'll have minus x to the 5th over 3 factorial, x to the 9th over 5 factorial, x to the 13th over 7 factorial, plus, dot, 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 plus. You know what I should have done is I should have closed the door at the same time, but I didn't. 4n plus 2 divided by x is 4n plus 1, and then over 2n plus 1 factorial plus dot, dot, dot. Okay, so our summation, this one has the same problem where 0 doesn't work. So, oh, also we're definitely starting at 1, right? Yeah, because we knocked off the term that was generated by n equals 0, right? That's what happens when we subtract this x squared from both sides. We're knocking off the term that is generated by n equals 0, so now we start at n equals 1. So n equals 1, then, and you can always check it, which is why I think building the series is a good way to go. 2n plus 1 factorial, comma, we know that x can't be 0 because we divided by x. So I think that's our answer. So you can use a calculator to confirm, like do the Taylor series built-in Taylor series, have it generate it, put in your summation to whatever, and just see if term for term it matches up. Alternatively, graph the function, graph like, I don't know, 10 or 15 terms of your series, see if it matches up. You need more terms when you're graphically checking, because like, I don't know if you remember a couple of videos back, I had done the problem like slightly wrong, and it was like almost right, but then I had more terms and it was still only almost right, and it wasn't converging correctly, and we discovered that I did the problem wrong. So those are the ways you can check it. You can also evaluate the function and the series that you wrote and see how close you are. A lot of options. All right, what do we want to do? Write a non-geometric series. Well, you can always write a geometric series, right? Just like pick R, whatever you want, a valid R value, and just do like first over 1 minus R equals the thing it sums up to. You'll always be able to solve for the first term that makes that happen. So it's kind of lame. So like it's always going to be non-geometric. E to the second power is just begging for you to use e to the x. So that's what I'm going to do. I'm going to do e to the x is 1 plus x squared plus x cubed plus dot 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 plus x to the n plus dot dot dot. So then e squared is going to be 1 plus 2 squared. Oh my god, over 2 factorial over 3 factorial. I forgot my whole. You know what I was doing? I was doing 1 over 1 minus x. I was doing geometric because we just talked about it. But when I got here, I was like, this is ridiculous. How could this be true? Because it's not true, so it can't be true. 2 to the n factorial. So sometimes you'll see these sorts of things. Like you'll see this and somebody's like, what does it equal? And don't get into, if you see a series of numbers, like of numbers, an infinite series of numbers, and someone asks you, what does it equal? It's gotta be one of the series that you have memorized. It has to be. So start looking. And when you start looking, you see factorials. You see just over n factorials, probably e to the what? And you're like, well, what did they plug in for x? They must have plugged in 2. It's e squared. That's how you can do that when you see a series of numbers and someone's like, they're not going to ask you unless you can do it. So there must be something that you know that applies to that situation. All right, this next one, think like what is equal to pi over 4? This is a big question. So I happen to know, and I'm not going to give you any time to like think it through really. Pi over 4 is equal to the, the only thing I can think of offhand, it's arctan or inverse tangent of 1. Like the inverse tangent of 1 is definitely pi over 4. So if I have a series for arctan and I plug 1 into it, it will be equal to pi over 4. So I'm going to find a series for arctan or tan inverse. And I'm going to do this by using something we talked about in the last set of notes. I don't know a series for arctan, but I know the derivative looks geometric. Right? 1 over 1 plus x squared, which is 1 over 1 minus negative x squared, which is the sum negative 1 to the n, x to the 2n, where the absolute value of x is less than 1. Okay, so that's a series for the derivative, which means that the original function should be a constant plus, we're going to integrate, right? So when you integrate, you stay at the same index, and then like sometimes you can move it in. I don't even know what it would mean to move it in this case, to go to like the negative first term or something, but whatever, we're not going to end up doing it. So don't you worry about that. Reverse power rule. Okay, you're tempted to put like parentheses and factorial, right? Because that's the denominator of sign. This is not a factorial, it's just 2n plus 1. I know that f of 0, the arctan of 0 is 0, which means that c is 0. So we definitely know that, well, I'm calling it arctan. I was calling it f of x, but I think it's better if I do arctan. Is this thing. So where does this converge? I don't actually need to know everywhere it converges. I just need to know if when I plug in 1, it converges. And if I plug in 1, oh, well, that's actually interesting because 1 is not in the interval of convergence for the derivative. But if I plug in 1, I get -1 to the n over 2n plus 1, which is definitely a convergent alternating series. So it converges at x equals 1. All right, so then I'm going to say that arctan of 1 is the sum -1 to the n over 2n plus 1. So that's a series that it converges to. I'm going to move everything over so that I can actually like write it. So here, okay, so this is actually kind of interesting, right? So that's pi over 4 is arctan of 1. And then this, if I plug in 0, I get 1, and then minus 1/3, plus 1/5, minus 1/7, plus 1/9, minus ... Look at that. Alternating sum of the reciprocals of the odds. Seems like there should be a better way to say that, but I don't know what it is. Which means that we could find pi, right? Pi, multiply both sides by 4. So if I put 4 times this, it equals pi. That's crazy. All right, would I expect you to do that on your own? I guess not, because I just did it with you. Would I expect you to be able to do something like that again? Probably. You see it once, then you kind of think about it, and then the next time you're struck with it, you're like, oh, I've done something like that. So I'm gonna end this video here. I'll be back in the next video to do some more, so I will see you there.